Hello and welcome to another webinar by the AM Academy. Now, right off the get-go, I want to apologize that this one is not live as we usually do. So normally every 2 weeks, we try to have a webinar at 10 CEST on our YouTube channel. But today, it seems that the YouTube servers and our network right here don't want to talk to one another. So I have no way to upload this live, no way to do this live, and instead, I just have to record it and then it will be uploaded later on. So it'll be there if you want to watch it at a later point in time. Uh, Sorry for the inconvenience, but it's just how it is for today. Now, the topic that we wanted to talk about today was 3D printing with supports. Why do we do this? Why are they necessary? Why don't we just avoid supports altogether? Well, it's a bit more complicated than just the question supports yes or no. So let's start at the beginning. What um, technique are we using? What process are we using for 3D printing? 3D printing is a wide field with a variety of um, different processes under this umbrella term. So for example, there's selective laser sintering, the SLS process. This uses a powder bed to successively melt parts of the powder bed until you have a 3D printed part. This process does not need any support structures whatsoever because there is always powder surrounding the printed part, and this powder supports any overhangs. So no supports needed there. Then something like DLP or stereolithography. In these processes, you always need supports for any hanging parts, and you can see these structures right here that are supporting anything that was built up. This is because in these processes, often the built platform is actually raised up out of a liquid, out of this resin, as it solidifies. And in that case, well, I need something to connect, this quiver on my elven statue to my built platform. So there's no way around supports on stereolithography, on DLP, anything like this. But what I want to focus on today is the FFF process, also commonly known as FDM, the fused filament fabrication, where a plastic spool of material, such as these right here, is melted and then deposited layer by layer using a nozzle. Now, the way this process works means that each successive layer needs something underneath it to support it. You cannot just deposit material into thin air. It'll droop down, it'll fall. And for these cases, we need support structures. But not every part that we print actually does need support structures. You can just, design a part so it doesn't need any supports at all. You can orient it so the supports aren't necessary. For example, we've got this little part right here. It's designed for a shelf like this. This was printed without any supports, and that is because all it consists of are horizontal walls on the platform, a vertical wall, and then sloped walls that don't exceed a certain angle. This is what you would call overhangs, where material is deposited along a gradient, and the previous layers support the later ones. And that way you can print a part like this without any type of support structures. However, you can also have something called bridges, where material needs to cross empty space, empty air, which would, for example, be the case right here in this little word. Every time with the crossbar of the A, that would be a bridge going from one side to the other. Now, when bridges are short and depending on your material, these bridges can be printed without supports. But if the distance is very long, if your material doesn't behave well with bridging, that's going to get difficult. And the last thing that is possible is floating features. In this case, I'll go for the C, even though it's not well visible. It's the best example I have here. Oh no, the S would work as well. So this part of the S right here, if I didn't have any of the white stuff, which is the support structures, this part of the S, the front, it would just float in thin air. The printer would try to deposit material where there is no support whatsoever. That doesn't work. So for stuff like this, we have to use support structures, 100%. There's just no way around it. The only other option we would have is reorient this so it wouldn't need support structures. So what if I printed this word ASA on its side? Well, I wouldn't have this nice bottom plate as big, but none of these letters would need support structures. So that's basically lesson number one. By designing your part or reorienting it in a smart way, you can avoid support structures altogether. There are two main categories of supports. There are breakaway supports and there are soluble supports. Breakaway supports are designed so you just break them off after the part is printed. Soluble supports can be dissolved either in water or in certain chemicals, leaving only the part that you actually wanted to print. Um, each of these categories, is subdivided a little bit, and we'll go through all of this now. First off, breakaway supports. For breakaway supports, again, there are two basic options, is you print them from the same material as your main part, or you have a separate support material. Now, printing them from the same part, I can demonstrate with this part, which was fiber reinforced plastic, um, fiber reinforced polyamide to be specific. And we canceled the print at some point because we were just testing something, but it's nice to demonstrate right here. I have these support structures in the holes that were printed. And because I only used one material, these support structures are made from the same material as the part itself, fiber reinforced plastic. Removing these support structures is actually going to take a lot of effort to break them out of there. And that was just the one that was still open to the top. Getting rid of these ones is going to be significantly harder and maybe impossible using just my bare hands. So printing the part and its support structures from one and the same material can actually require a significantly higher amount of post-processing work and effort put into the part after the fact. However, there are also some benefits to this. For example, if you have a printer with only one nozzle, this is going to be the only way you can print with supports. You have to make it from the same material, you only have one nozzle. But even on dual nozzle printers, such as the E2, it can be beneficial to print your part and its support structures from one and the same material. For example, if you want to use mirror or duplication mode. Now on the Pro 2, for example, you have two nozzles. You can print two different materials, a main print and a support material, just as an example. That would work fine, but on the E2, you have the IDEX system, the independent dual extruders, and these are capable of printing independently from another. Each nozzle has its own little print head that can move independently. And with this, you can use the mirror or duplication mode, which means you print two models at the very same time. However, in that case, once again, each model is limited to one material, meaning you would have to print your part and its support structure from one and the same material. So, pros and cons there. The other way to print breakaway supports is from a different material, such as we did right here. Now, the top part of this tubing, it's an air intake for a scooter, is printed from a flexible TPU. The base is made from PLA. Because the tube is round and would not have a lot of surface contact with the built platform when printing, trying to print it without this red platform would actually not work. However, with the red platform, we just printed it, and because it's flexible, we just squished it afterwards, and the red platform came right off. This part of PLA we would throw away and be left with only our flexible tubing, which worked really, really well. This is just a basic case where we use PLA as a support material. PLA is, one of the most commonly used materials in FFF printing, but not specifically designed to be a support material. We just found that it works really, really well with this TPU. However, for example, with this fiber reinforced material, there is a dedicated breakaway support material, this purple stuff. It is specifically designed to work with this specific fiber reinforced material and can be broken off with a little bit of force. You can, of course, also use other breakaway materials. I could use PETG to support the PETG part, but a different type. The problem here is that you never want your part and your support material to fuse so tightly together that you then cannot get rid of it after the fact. So, breakaway support materials. If you use one and the same material, you will have difficulties removing the supports, but you can use it on a single nozzle printer or with a mirror or duplication mode. If you use a separate support material that was specifically designed to be a support, well, you will have an easier time getting rid of it because that's what it was designed for, but it's still trash. You do need two nozzles now. However, in some cases, it is just the best possible way. With polypropylene, for example, the P filament, there's a dedicated support material, the P support. And this is something that you would heat to 110 degrees, for example, in an oven, and then you can peel it right off the part. So it's breakaway in a sense where you don't dissolve the material, but you take it off the part after the fact, but it gets this chewing gum-like substance, and then you just peel it off. And it's actually a great way to support these polypropylene parts, which are otherwise often very difficult to print and don't have other dedicated support materials. But what about the soluble ones that I touched on earlier? Now, soluble supports are a chapter on their own. There are different types. You can have certain materials that dissolve in water, such as PVA or BVOH. These are really, really cool because you can use these to print parts, and then afterwards, you just throw your part in a bucket of water, let it sit for a few hours, and take your part out, all the support material is gone. Traditionally, this was mainly PVA, polyvinyl alcohol. However, by now, BVOH has been developed and is mostly just straight up superior. The problem with PVA is, A, it takes pretty long to dissolve, and it's not compatible with a wide variety of materials. So for PLA, PVA works really well. But if you want to print, I don't know, PEEK, some of these ultra high strength materials, you're going to struggle with that. BVOH not only dissolves considerably quicker when placed in water, it is also not as susceptible to humidity in the air in the room that it's stored in, and it's able to be paired with a much more different materials. So PETG, ABS, I don't know, polycarbonate, all of these would all work with BVOH, where PVA might sometimes struggle. Now, I mentioned susceptibility to humidity, and I've got this little measurement device. I don't know whether you can see it, but we've got about 54% humidity in this room right now. If I stored my BVOH or PVA filament for a prolonged amount of time in this room, it would absorb moisture from the air, then be wet, and not be able to be printed very nicely. If I put a wet BVOH filament into my printer, the water inside will actually boil, that's the word I was looking for, and the resulting air and vapor will absorb a lot of the heat in the hot end. It'll lead to clogged nozzles. It won't look nice in your print. You'll have gaps in the material feed, all of these things, so you really, really don't want that. You do not want to print wet material. So instead, you would need something like a dry box. Now you can build these yourself out of, I don't know, IKEA boxes and stuff like that. There are plenty of instructions online, or you get one of the poly boxes with a humidity measurement on the front, and then you have desiccant on the inside. This would be the preferred way to store one of these water-soluble materials. Water solubility is great because everybody has water at home, but over time, I am not certain how much longer we'll be able to just dump the wastewater resulting from this into the drains. Right now, it's still possible, but as the discussion around, plastic waste, microplastics proceeds, I think that as well will be limited at some point. What are your alternatives? Well, one of the most well-known and most common combinations would be ABS with hips. Now, this T-Rex skull right here, this is made out of ABS with hips as a support material, and hips is soluble in limonene, a chemical. I could also just break this off. It's already quite brittle and fragile. This T-Rex skull has been standing around for a while. And in this case, that would work. On this T-Rex skull, I could just break it all off and I would probably be fine because all the support material is easily reached. However, if I, for example, take this little elbow pipe, there's no way to get rid of all the stuff that is inside. Sure, I can break away the parts on the bottom like this, but getting at everything that is stuck inside the pipe would be really difficult. And maybe I could even do it for the short one because, well, the distance isn't very great. I can maybe get something in here and out the other side. But imagine this pipe was coiled a couple times, or was a lot longer, or even just much thinner than this one. I would have real difficulties getting at the support material on its inside. And in these cases, the soluble material is great. I just chuck this into the chemical and everything inside dissolves, leaving me with just my part. Disadvantage, I need the extra material, I need 2 nozzles, and I have wastewater that I am not always, most of the time, but not always, allowed to just dump into the drain. Aside from these, though, there is a wide variety of third-party manufacturers, for example, VXL, which is a company that I want to mention a bit more in a bit more detail now, because we've got a lot of example parts from them, and it's actually been working really, really well. So their concept is, okay, we'll develop multiple different support materials that are all soluble with our stuff. So basically, there is a VXL, let me get rid of this one. There's a VXL 70, which is the lowest grade, which you can use with PLA, for example. There's a VXL 90 that you can easily use with ABS or stuff like that. And then it goes all the way up to, I believe, a VXL 130, which you can use with PEEK, with Ultim, these really high temperature, really high strength materials. So with their portfolio, you can actually supply all different types of parts that you may want to print. And afterwards, this is basically what it looks like. This is the fully supported part with the VXL material around it, and this is the clean part where all of the support material has been dissolved away. And I am left with just my part with exceptional surface qualities considering it has been supported. And when you do support a part, the surface where it was supported will almost always suffer a bit. But on these ones, it's really nice. And yeah, it can save you a lot of trouble. And because these materials are available for all sorts of different, you know, strengths categories, I don't know, for all different temperature ranges, that's more accurate. So you've got the 70 for the PLA, the 90 for ABS, and the 110 for polycarbonate, and the 130 for PEEK, for example. Something like this. Don't nail me down on this. And then afterwards, you can wash these out. Now, it is a bit more complicated than just chucking them in water. So the VXL 70 and 90, you can very easily wash out using something like this. They sell this little plastic bucket, and then you have a pump to get water into the plastic bucket. On the inside, there is some accessories. That's the word I was looking for. Most importantly, the VXL Sol. This is the chemical that you need to put into the water so that support material actually does get dissolved. Then you place your parts into the water using the tongs. And last but not least, you take this sous vide thing and just get it through the hole into the plastic bucket and then leave it in there for a certain amount of time. And during this time, all the support materials will be dissolved. Now this setup right here is kind of janky, I guess, but it really does work. However, it only works for the VXL 70 and the VXL 90 because these are the low temperature ones. You can't get the temperature inside this bucket more than 60 degrees. For the higher temperature ones, there are dedicated washers. But this is a really cheap and easy to use setup for the lower tier, let's call them that, support material. So if you're planning to print with PLA, with ABS, something like this, and you need a dedicated support material, this is actually a great choice. What else did I want to say? Yeah, as I mentioned, you can also break away the hip support. However, for example, on these very delicate drone propellers, if I just snapped off the support material, the white stuff, it's quite possible that I would also damage the propellers. So instead, for this one, for example, I would want to dissolve that one in limonene. Oh, right, because I mentioned earlier at the start how the sloping is actually paramount for when you need support materials or not. This is extremely material dependent. And to figure out what are the, you know, the breakpoints for the material that you in specific are using on any given day, you can print these printer tests on your machine. You can see we have a bunch of them here made out of different materials. And for each one, I can then see how well the overhang section worked and at what point the material quality is so bad that I say, okay, I don't want to have this on my part anymore. That's where I would need support structures. So printing these printer tests with your different materials gives you a good idea of what your specific material and your printer are capable of doing with what settings. You play around with this. If you optimize the cooling, the temperature, and the printing speed of your machine, you can get the most out of your material and probably avoid supports for almost all cases. But as I've said, almost all is not completely all. There are some cases where you absolutely do need supports, such as cavities, unsupported bridges, very long bridges, maybe even this pipe on the inside if you want the top to look very nice. If you have free-form shapes, for example, on this orthesis, the foot sole, that's not a flat surface. It is going to be curved, and that is not something a 3D printer traditionally does well with. So instead, you would want a support material underneath. Okay, I think that covers most of what I had to tell you today. Thank you very, very much for watching. If you do have any questions or comments, please leave them below. I hope this was informative to you, and I hope to see you next time, hopefully again live on our YouTube channel right here. And if you are interested in anything pertaining to 3D scanning, if you like 3D printing, anything like that, do subscribe to the channel because we'll be uploading more and more videos about these topics as time goes by. Thank you once again very much for watching, and see you next time.